Okay, hello and welcome to another video where I'm going to be discussing about the effects that climate change is having on waves. Quite an interesting topic actually, because I myself kind of had an idea, but not to this extent, of the effects that climate change and global warming may be having on the frequency and height of certain waves, which will in turn affect the coastal ecosystem as well as infrastructures built on land. But we'll get into that in the video. So yeah, let's roll that intro and get started. Okay, so currently we've already seen or are seeing or have heard of or noticed the current effects of human-induced climate change and global warming on the planet, whereby a lot of the environment as well as the animals within that environment and us are struggling to cope and or adapt to the rapid changes that are happening in the ecosystem. We see this with a bunch of global temperature deviations, with sea ice melting faster than predicted, with a lot of species nosediving towards extinction, with the land being swallowed faster by the sea than we have predicted, with the earth drying faster than predicted. So yes, we see this already, it's already apparent. Even if you're one of those people that deny the effects of climate change, the evidence is there. So yes, we've got that to worry about. But now we've also got the effects of climate on wave patterns and or the frequency of those wave patterns. So research from Griffith Cities Research Institute and Griffith's Center for Coastal Management have found effects of climate change and global warming on frequencies of wave action as well as height. And what they found was that wave frequencies were increasing by 5 to 15%, and their direction in which they were hitting the land was shifting by 5 to 15 degrees. However, it was projected that if the prediction from the Paris Agreement for the temperature threshold being roughly 2 degrees remains there and we do not go above that threshold, then wave frequency and height are probably not going to go past the modeled figures in which they are working from. But if these temperatures go above 2 degrees Celsius and we continue to go on our normal means of what we're doing currently, then yes, we are going to see major infrastructural changes, we're going to see major coastal environmental changes, and we're going to see major ecosystem and migratory pattern changes along every coastline. Under a high emission risk scenario, which is currently what we are going towards if we do not slow us down, they've predicted a 50% increase in climate wave action. And what this means is that a lot of the coastal land that most people are going to be living on will be inundated, or a lot of the beaches won't be there anymore. There's predictions that less than 5% of global coastlines will be affected from increased wave height and frequencies. These are included, but not limited to, Australia, the South and Central of America. There's also predictions that 15% of every other part of the world will show decreased wave height and action. However, wave height is not the only issue. We've also got the frequency at which the waves meet the shore, and this poses a whole nother problem. The problem here is that a lot of the waves that reach the shore bring sediments with them from all over the world, okay? And a lot of those sediments are the sands on the beach. Now, if we've got waves hitting the beach at different angles than normal, and the frequencies change, as in we're not getting as much waves or we're getting too many waves, then that landscape is going to completely shift, and that's going to affect a lot of infrastructure and a lot of ecosystems. So essentially the process is they'll crash up onto the land and deposit a bunch of sediment. They'll then bring some of that sediment back, and the cycle repeats, crashing, dumping, and bringing it out. But the predictions show that 20% of global coastlines will experience less frequent waves or changes in the direction at which these waves are coming in, which will mean, or possibly show that a lot of infrastructure and businesses that rely on this land are going to have major changes or potentially become inundated. So I just explained what's happening. We're seeing changes in wave frequency and wave height because of the effects of climate change and global warming. We know that. But how is this happening? Okay, I've explained what, but how. Here's how. Waves are formed by the creation of mainly wind as well as multiple other factors such as the moon, the sun, the rotation of the earth, the axes of which, there's a lot of stuff. But we're going to be talking about the wind. The wind that pushes along the surface of the water creates the waves that you see, right? A lot of these wind speeds are now increasing because of the effects of climate change and global warming. This is going to in turn affect the future and therefore creation of a lot of waves that meet our coastlines, changing everything. Recent research has investigated the effects that climate change and global warming are having on wind speeds globally. And what they discovered were that wind speeds are increasing by 1.5 meters per second. What this also means is that a lot of the wave action and height has increased by roughly 30 centimeters. This is about a 5 to 8% increase since historical records. The upper ocean has gradually been warming, okay, from the increase or the amount of greenhouse gases in the atmosphere causing a blanket which traps the heat. The ocean's the biggest carbon sink. We're taking up a lot of carbon in the oceans, increasing the surface temperature and therefore increasing the strength of the wind that ultimately will hit the surface of the water, creating stronger, more frequent, larger waves. In fact, Borja G. Riguero, I butchered that, I'm sorry. The study's lead author has stated, wave power has increased globally by 0.4% per year since 1984, and this increase is correlated with the increasing sea surface temperature both globally by ocean regions. The one thing I want to stress here is that much of this data is met with a bit of uncertainty. This is primarily because it's difficult to track climate and the effects on the waves. What we do know is that wave height is increasing. That's quite easy to track. We just track how big are the waves over time. The problem here is that if there's uncertainty or anomalies within the data kind of loses some, not all, not much, but some of its credibility. The fact of the matter is, temperatures are increasing, wind speeds are increasing, wave height and frequency are possibly increasing over time. We are seeing huge increases since 1984, and we do know that a lot of the waves are getting bigger. So, the solution? Maintain the Paris Agreement threshold of 2 degrees Celsius and we won't see much of a change, or we won't see a change that's going to be drastic to the point in which adaptation cannot handle it. If we continue to go about our business and do exactly what we're doing now, then things are going to get kind of rough. It's going to get crazy. We're going to see large changes in our coastlines. We probably won't have beaches, and we probably won't be able to live closer to the shore. Predictions already state that a lot of the coastal lands that are now there are not going to be there in maybe 50 to 100 years. It's kind of hard to grasp, I get that, but those are the facts. Alright, and that's that. There wasn't much to go off of for this video. As I said, the data is met with a lot of uncertainty. There wasn't much I could find that actually I could, I guess, relate to you, or stuff that was free for me to use. So it was kind of difficult. So I hope you liked that video. I'll see you guys in another video. I hope you liked that one. I've already said that. Make sure you educate, don't eradicate. Check out Cape Clasp. I'll chuck some more information down below about this topic if you want to check it out. And yeah, subscribe, like, comment, do all the cool stuff. And I'll see you in another video. Catch you later.